Hello and welcome to the data analysis section of the lecture series for this week. So we'll be looking at SPSS and we'll be looking at t-tests to start with. So the major program for conducting these parametric tests in SPSS is called the compare means. And this program can be used to conduct the t-tests on one sample, independent samples or paired samples. To select these procedures using SPSS for Windows, we click first of all Analyze, Compare Means, and we can do the one sample t-test, the independent samples t-test, and the paired samples t-test. And we can illustrate these using the detailed steps using the data of table 12.1. And I've preloaded that into my SPSS, and I've got table 12.1 ready to go. And this is the data here. So first of all, when we're going to run an example, we're going to do an example of this. We're going to select the data from the SPSS menu bar, then select cases, and then check if condition is satisfied, then select the if button. So let's do that first. We're going to go in here, and we're going to go data, select cases. Now at the moment all cases are selected, so we want to do if. We're going to go if here, and we're going to pick the move the sample into the select cases if box, and then click equals, then click 1, and then continue with that. So we're going to do sample in there, sample equals 1, click continue, and click OK. Now this output file is going to run and tell us what it's doing, and if we look at our data set now, it's selected all of the cases for sample 1, and all of the cases for sample 2 have been excluded. And the reason why we're doing that, if we go to our textbook, we can look at the one sample t-test there, and we've got here for our example we're going to test so for one sample t-test is illustrated using table data in table 12.1. The null hypothesis based on the previous is that the mean preference for sample 1, so we're only testing the teenagers before entering Yellowstone Park, will be 5. So because we're only testing sample 1, we have filtered out all of the sample 2 cases, and we're only left with the sample 1 cases. Alright. So the next one is we click OK, then we can click Analyze from the SPSS menu bar, click Compare Means, and the one sample t-test. So we go back to SPSS, we go Analyze, Compare Means, one sample t-test. Right, now in here, we can move the preference before visiting into the test variable box, and the test value is 5. So we go back to here, and we got the preference before visiting into there, and the test value is going to be 5. And the reason why the test value is 5 is when we look at what we're doing here, we're actually testing to see if the average for the population is 5. So we can see it here. So what we're trying to test is if we've drawn a sample from the population, but we want to test if the actual population average is likely to be 5. So we've done all that, and then we click OK, and it runs our test, and it gives us this data output. And what we're looking at here is the level of significance, which is less than our half alpha. So that's that one there. So I'll just go back to our textbook here. We're going to look at the output that we got and the output that's in the textbook, just to compare them. So so you can see the difference, or what the similarities probably. Alright, so what I'll do is I'll scroll the textbook. Yeah, see, I'm at the bottom of the textbook, that doesn't work. Alright, so in here we can see we have n, so which is good to know. So in our textbook it's 10, and our output it's 10, because we had 20 to start with, but we filtered 10 out, so that's good to know. The mean that we calculated, now I'm going to go back to our data file, so the mean of all these ones actually works out to be 5.5, and it tells us that. So 5.5 there, and the standard deviation is 1.08, which shows us how spread out it is, and the standard error of the mean. Now, the one that we're looking at, so this SPS output gives us our t statistic and our degrees of freedom, which is n take 1, so 10 take 1. And here, this so the t statistics are there, and the one that we're looking at is the two-tailed significance, which is 0.77, or in our one here, 0.77 there. Now, we can see that that's greater than our half alpha, so we cannot reject the null hypothesis. So that is how we run the one sample t-test. So we cannot reject the null hypothesis, which means we cannot accept the alternate hypothesis. Alright, so we'll run now to this next one, which is the two independent samples t-tests. So before we, the one that we just previously, we grabbed a sample out of the population and we compared our sample to the population. Now we're going to compare two samples with each other. So first of all, we need to make sure that all cases will be included in the analysis. So we go back to our SPSS and we'll go, in the menu bar, go data, select cases and choose all cases. So let's do that. So in our SPSS, all these cases have been deselected. So we go data, select cases, and we go all cases. And we click OK, and now it just tells us what we've done, filter off. And all of our cases are selected now. So now we're dealing with 20. So that's good. Go back to our slide. So then we select analyze from the SPSS menu. We do compare means and we do independent samples t-test. Alright, so let's do that. So we go analyze, compare means, independent samples t-test. Right, and then brings up our box. Now what I want to do is bring up our textbook. So we're going to go back one. We've done our one sample. Now we're going to do our two independent samples test. Do means. Alright, now for here we have the hypothesis is formulated as the average for population 1 is equal to the average of population 2. Alright, so what was the test? So in here we were testing for so using the data table 12.1 we can examine whether the teenagers have a different preference than adults, and that way we're going to say, well, the population 1 is going to be the teenagers and population 2 is going to be the adults. Alright, so let's go back to here. So we do analyze, we've done that. Now next bit is we're going to move preferences before visiting into the test variables box. So, sorry, wrong. Preference before visiting into there. Alright, and then we're going to type, so then we go to click define groups. Oh, so we've done the preference before visiting. We're going to do the move the sample into the grouping box. So in here, sample into the grouping box. Now you can't run it yet because we need to define the groups first. And our group 1 is actually going to be our data point 1, and group 2 is our data point 2. So we click continue. That does that. All right, and then we click continue and OK. Click continue and OK. And that's going to run our data analysis. It's going to pull that out there, and it spits out this output. Alright, so let's have a look at our textbook then. So in our textbook this was our output for the independent samples, and looks very similar to ours here. So in here we had 10 teenagers and 10 adults. The mean for the teenagers is 5.5 and the mean for the adults is 4. So the average, so teenagers had a higher response before going into part than adults. Now in here, we first of all did the Levene's test for equality of variances, and it gives our F statistic in our 0.70, and that means this Levene's test is not significant because it's greater than our half alpha, right? But we look at our significance here, so that means that we can't assume that the variances are equal. But for us, it's not too important because the equal variance is assumed is the same as that equal variance is not assumed. And our significance is 0.006, which is way less than our half alpha. So we actually can say that the groups, the teenagers and the adults are significantly different. All right, and that corresponds with what we've got here. So that's got the 10 cases with the means and stuff like that. This is our Levine's test in there, and here is our two-tail significance, which is 0.006, which is significant. So in here, under our null hypothesis, the value of the t-statistic was 3.14, which is the same as what we had here, 3.14. And this gives a probability of 0.006, which is less than significance level for our half alpha of 0.025 two-failed test. Therefore, the null hypothesis of equal means is rejected, and the conclusion that the teenagers and adults differ in their preferences for Yellowstone National Park. All right, fantastic. So that's the two independent samples t-test. Now we're going to do our paired samples t-test. So the previous one was independent samples, these are going to be paired samples. So the first thing we do is we go select data, we go select cases, and we select if condition is satisfied, the if button, then we move the sample into for 1. So we're going to select our sample 1s again. Alright, so go back to here, and we go data, select cases, sample, if condition is satisfied, if sample. So this actually remembers what we did last time, alright? So if sample equals 1, click continue, and click OK. Now it tells us that it's filtering it out. And we look here, and now only sample 1 cases are selected. So these are sample 1, these are sample 2. Only our sample 1s are selected, which will be included in the data analysis. And the reason why we do that is because if we go to our textbook, we go back to the paired samples test for means. We're actually only going to be testing the for the data given table 12.1, which we've got open at the moment. Lost it. For, data for 12.1. The paired t-test should be used to determine if there's a difference in preference before preference 11 and after preference 12, visiting for respondents in sample 1. So you can read the blurb. I won't do the whole lot, but we're only testing sample 1. So we've filtered out our sample 2, so we're only testing sample 1. Right. Now we click OK, and then we can go Analyze from the SPSS menu bar, click Compare Means and the Paired Samples t-test. So we go here and we go Analyze, Compare Means, Paired Samples t-test. Alright, cool. Now we click, so now we've got to select preference before visiting and select preference after visiting. Preference 1 and preference 2. Preference 1 and preference 2. And you can see here, it's actually grouped them in the same pair, pair 1, right? And the reason why this is a paired samples t-test is because we're measuring the people's preferences beforehand and their preferences after. And it's the same people. So respondent 1 gave us from sample 1 gave us a score of 7 first and then a score of 9 afterwards, right? And respondent 2 gave us a score of 6 first and then 8 afterwards. And this is important because those two are obviously paired because it's the same person before an event and after an event. Whereas if that's the same person, obviously there's a pairing going on there. You can't say that they're independent of one another. Whereas if we drew 2 independent samples, or we had like males and females, or we had adults and teenagers, they are independent of each other, right? Being an adult, someone being an adult doesn't impact someone else being a teenager. But my rating, so that's independent of each other, but my rating before I go into the park is obviously influenced by my, is going to influence my rating after going to the park. So they are paired. Alright, cool. So we've done that, we do compared means, then we go, done that, variables into the paired box, then we click OK. Alright, and click OK. Right, and it runs this the paired samples statistics. And what I'm going to do is pull this up in this textbook here so we can compare it, and we've got much the same data in there. So let's have a look, try and make some sense of this output then. So we've got the mean for the preference before visiting, so what's the average scores, and preference after. So we know that it goes up. And we had 10 data points before, 10 data points out, and this is standard deviation and standard error. Now, the preference before visiting and the preference after. So we've actually paired these up. Now we're looking at, so this gives us a correlation and a significance here. And it's significant, the correlation is significant, but what we're really interested in is this paired samples test. And it gives us a mean difference. So the mean, I'm just going to go back to our data point here. So the average for preference 1 was, actually tells us this in our data, and our output was 5.5, and the average after was 7.9 of those ones. So the average scores of those was actually, where did it go? 7.9. So there's a difference here. It's actually of 2.4 with a standard deviation. Now with standard error, and it gives us here our significance right here of 0.000. So it's less. We say it's less than 0.00 because 1, because you can never be completely 0. SPSS obviously just does the rounding and spits it out to 3 digits, but in real life you can never be 100% sure of something, and this is kind of indicating that it's 100% sure that you haven't got a type 1 error, so you can never really be 100% sure, so we can say we're 99.9% sure, right, which is statistically more accurate. And so that's the output. Now we look at our box here, and this is on our textbook at page 369, and the data is the same. I'm just going to bring this on the top of it. So our significance, so we had the difference of mean was negative 2.4. The standard deviation was 0.516. It gives us our standard error of the mean. We've got lower and upper. Don't really need to worry about that. That's when we've got two-tailed tests. It's where that t-point ends up on the on each side of that tail. We don't go into that much detail for this course because the SPSS does a lot of the data analysis for us, so it's not too bad, right? And here we have our significance, which is the same as there. So when we've got a significance that that low, we can say because the p-value, our two-tailed significance, is less than 0.025, which is a half alpha. Because remember, we set our confidence level at 95%. So if our confidence level is 95%, our alpha is 5%. And because it's a two-tailed test, we got 2.5% on one side and 2.5% on the other side. So we go 0.025 is that 2.5%. And because it could be either one, we go, well, this statistic here, this two-tailed significance p-value is actually less than our half alpha. Therefore, the preferences of teenagers before and after visiting the park are significantly different. It's as simple as that. So we can, because it's significant, we can reject the null hypothesis and then accept the alternate hypothesis that they are different. All right, so that brings us to the t-samples. The next one we're going to look at correlation and regression. All right.